The history of science is often presented to us as a pristine marble hallway lined with the busts of great men. We are taught to revere the fathers of our modern understanding: Darwin, Newton, Einstein, and in the realm of climate science, John Tyndall. For over a century, the narrative has been set in stone. We have been told that in 1859, the Irish physicist John Tyndall, working with complex custom-built brass apparatuses in the hallowed halls of the Royal Institution in London, became the first human being to demonstrate the greenhouse effect. He is credited with discovering that certain invisible gases, specifically water vapor and carbon dioxide, have the power to trap heat, acting as a blanket around our planet. It is a neat, tidy story of Victorian male genius, a story of expensive equipment, institutional funding, and the inevitable march of progress led by the beard-stroking elite of the 19th century. But this story is a lie. Or, at the very least, it is a convenient half-truth that has persisted for 160 years. The history of science is often presented to us as a pristine marble hallway lined with the busts of great men. 3 years before Tyndall's famous experiment, 3 years before the father of climate science had his revelation, the discovery had already been made. It did not happen in a well-funded European laboratory. It did not involve expensive brass spectroscopy equipment. It happened in a backyard in upstate New York, using tools that you could find in a kitchen. The year was 1856. The scientist was not a man seeking glory in the Royal Society. She was an amateur researcher, a suffragette, and a woman named Eunice Newton Foote. And she didn't just discover the greenhouse effect, she looked into a glass jar and saw the catastrophic future of our planet. To understand the magnitude of what Eunice Newton Foote achieved, we must first transport ourselves back to the scientific landscape of the mid-19th century. It was an era of obsession with the Earth's history. Geologists were arguing about the age of the planet, debating whether the climate had always been the same or if it had shifted violently over eons. They knew that the Earth had been warmer in the past. They found fossils of tropical plants in cold regions, but they had no mechanism to explain why. The prevailing theories involved changes in the sun's heat or shifts in the Earth's orbit. The idea that the atmosphere itself could change the temperature was a radical, untapped concept. The air was viewed largely as a transparent medium, a passive ghost that simply allowed sunlight to pass through. Enter Eunice. She was not a professor. She held no chair at a university. In 1856, women were effectively barred from the upper echelons of higher education and scientific societies. But Eunice possessed a mind that refused to be confined by the domestic sphere. She was an inventor, holding patents for stove regulators and vulcanized rubber inserts for shoes. She was a thinker who looked at the physical world and asked questions that the men in their ivory towers hadn't thought to ask. While the establishment was looking at the sun or the orbit, Eunice decided to look at the air itself. Her experiment was elegantly, deceptively simple. It was the kind of simplicity that characterizes true genius. She didn't need a massive laboratory, she needed logic. She gathered a collection of glass cylinders, likely simple jars used for preserving fruit or chemical specimens. Into these cylinders, she introduced 2 thermometers each. Then, she manipulated the atmosphere inside them. She gathered a collection of glass cylinders, likely simple jars used for preserving fruit or chemical specimens. In one cylinder, she condensed air to a high pressure. In another, she pumped the air out to create a vacuum. But then she went further. She filled one cylinder with ordinary, moist air. And in another, the most critical one, she filled it with what was then called carbonic acid gas. Today, we know it as carbon dioxide, CO2. She placed these glass vessels side by side in the direct, blazing sunlight of a New York day. And then she waited. She watched. She recorded. This was science in its rawest form. No assistants, no grants, just a woman and the sun. As the minutes ticked by, the mercury in the thermometers began to rise. In the vacuum, the temperature barely moved. In the ordinary air, it rose steadily. But in the cylinder filled with carbon dioxide, something alarming happened. The thermometer didn't just rise, it spiked. It reached a temperature of 125 degrees Fahrenheit, far hotter than any of the other jars. But Eunice noted something else, something even more profound. When she removed the jars from the sunlight and placed them in the shade, the cylinder with the CO2 refused to cool down. It held on to its heat, clutching it like a miser with gold. The other jars cooled relatively quickly, returning to ambient temperature. The CO2 jar remained hot, a stubborn pocket of fever in the cooling evening. In that moment, staring at a simple glass tube, Eunice Newton Foote made a cognitive leap that spanned centuries. She connected the behavior of the gas in that tiny jar to the behavior of the entire planetary atmosphere. She realized that the air wasn't just a passive window, it was a blanket. And if you changed the composition of that blanket, if you added more carbon dioxide, you wouldn't just warm a jar, you would warm the world. In that moment, staring at a simple glass tube, Eunice Newton Foote made a cognitive leap that spanned centuries. She wrote down her conclusion with a clarity that is chilling to read today. There was no hesitation, no hedging. An atmosphere of that gas would give to our Earth a high temperature. Let those words sink in. An atmosphere of that gas would give to our Earth a high temperature. This was 1856. The internal combustion engine was in its infancy. The massive burning of fossil fuels that would define the 20th century had barely begun. Yet here, in a backyard experiment, a woman had predicted the defining crisis of our modern era. She had discovered the greenhouse effect. She had identified the culprit, CO2. And she had predicted the consequence, global warming. She had done it all before John Tyndall had even started designing his equipment. She held the secret to the Earth's climate in her hands, written in ink on a piece of paper, waiting to be shared with the world. She was the prophet of the Anthropocene, standing alone in the garden, listening to the silent warning of the mercury. But as she would soon find out, making a discovery is only half the battle. Getting the world to listen, especially when you are a woman in the 19th century, is a war entirely of its own. Eunice Newton Foote had the data. She had the proof. She had the vision. Now she needed the platform. In August of 1856, the American Association for the Advancement of Science, the AAAS, was holding its annual meeting in Albany, New York. This was the premier scientific gathering of the time, the place where the greatest minds of the nation congregated to share discoveries, debate theories, and shape the future of human knowledge. It was the natural place for Eunice to present her findings. Her paper, titled Circumstances Affecting the Heat of the Sun's Rays, was a concise, powerful document of empirical science. It deserved to be the headline event. But there was a problem. A structural, insurmountable problem inextricably linked to the social fabric of the era. Eunice Newton Foote was a woman. In the mid-19th century, the scientific community was not just male-dominated, it was exclusively male-defined. Women were occasionally permitted to attend these meetings, but usually only as spectators. Wives, daughters, or curious amateurs tolerated on the fringes of the serious discussions. The idea of a woman standing at the podium, commanding the attention of a room full of bearded, frock-coated academics and lecturing them on the fundamental physics of the atmosphere was virtually unthinkable. It would have been seen as improper, perhaps even scandalous. So, when the day came for her work to be presented, Eunice Newton Foote did not walk up to the stage. She did not clear her throat and address her peers. Instead, she was forced to sit in the audience, hands likely folded in her lap, watching as a man took her place. Eunice Newton Foote did not walk up to the stage. Instead, she was forced to sit in the audience. The man was Professor Joseph Henry, the first secretary of the Smithsonian Institution. He was a giant of American science, a man of immense respect and authority. There is a tragic irony in this moment. Joseph Henry was not a villain in the traditional sense. He was a gatekeeper who thought he was being benevolent. He had agreed to present Eunice's paper, which in itself was a concession. But his introduction of her work has echoed through history as a masterclass in unintentional erasure and patronizing dismissal. Before reading Eunice's revolutionary words, Henry felt the need to preface them. He reportedly stated that science was of no country and of no sex. On the surface, this sounds noble, a declaration of equality. But in the context of 1856, it was a defense mechanism. It was an apology. He was essentially saying to the room, "Don't worry, gentlemen, I know this is a woman's work, but the data is valid despite her gender." It was a compliment that stung like a slap. It highlighted her otherness. It framed her not as a scientist, but as a female anomaly who had stumbled upon a scientific truth. Henry read the paper. The audience listened. And then, nothing happened. There was no uproar. There was no rush to verify her findings. There was no realization that the key to Earth's climate history had just been handed to them. The paper was politely received and then promptly filed away. When the proceedings of the meeting were published, Eunice's paper wasn't even included in full. It was reduced to a short abstract, a mere few paragraphs that stripped away the detailed data tables and the urgency of her conclusions. It became a footnote, a curiosity, the lady's science. Contrast this silence with what happened 3 years later in 1859 across the Atlantic. John Tyndall, a man with the full weight of the British scientific establishment behind him, began his experiments on the absorption of radiant heat by gases. Tyndall was everything Eunice was not: professionally employed, well-connected, and male. He constructed a sophisticated differential spectrophotometer, a beautiful, complex beast of brass and glass tubes, far more advanced than Eunice's simple jars. He constructed a sophisticated differential spectrophotometer, a beautiful, complex beast of brass and glass tubes. When Tyndall confirmed that carbon dioxide and water vapor absorbed heat, the world listened. He published in the Philosophical Transactions of the Royal Society. He gave lectures that were the talk of London. He was lauded as a pioneer, a genius who had unlocked the secrets of the atmosphere. He wrote, "The atmosphere admits of the entrance of the solar heat, but checks its exit, and the result is a tendency to accumulate heat at the surface of the planet." It was essentially the same conclusion Eunice had reached 3 years prior. Did Tyndall know about Eunice? It is a question that historians have debated. The scientific world was smaller then. Journals traveled across the ocean. It is possible he missed the brief mention of her work in the American journals. It is also possible he saw it and dismissed it as the inconsequential dabbling of an amateur. Whether by malice or by simple structural negligence, the result was the same: erasure. Tyndall became the father of climate science. His name was etched into textbooks. Laws of physics were named after him. Eunice Newton Foote returned to her life in New York. She continued to invent. She continued to fight for women's suffrage. She was actually a neighbor and friend of Elizabeth Cady Stanton and signed the Declaration of Sentiments at Seneca Falls. But her contribution to climate science was effectively dead. The polite applause of the men in Albany had drowned out her warning. The gatekeepers had taken her discovery, patted her on the head, and then buried her legacy under a mountain of indifference. For the next century and a half, if you asked any scientist who discovered the greenhouse effect, they would say John Tyndall without blinking. Eunice wasn't just forgotten, she was unwritten. She became a ghost in the machine of history, a phantom signal that had been filtered out as noise because the source didn't match the expected frequency of great man of science. For over 150 years, Eunice Newton Foote remained in the darkness. The 20th century roared by. We burned coal, oil, and gas at rates that would have terrified her. the atmosphere filled with the very gas she had tested in her backyard. The global temperature began to rise, just as she had predicted. Climate science grew from a niche curiosity into the most critical field of study for the survival of humanity. Thousands of papers were written, referencing Tyndall, Arrhenius, and Callendar. The history of the field was codified. And nowhere in those bibliographies, nowhere in those citations did the name Foote appear. She was effectively extinct from the historical record. It wasn't until the digital age, until the dusty archives of the 19th century began to be digitized and searchable, that the first cracks in the wall of silence appeared. But the real vindication came from a serendipitous moment of curiosity in 2011. Ray Sorensen, a retired petroleum geologist, was strictly a hobbyist when it came to history. He was an avid collector of old scientific books, the kind of volumes that usually end up rotting in basements or being sold by the pound for decoration. One day, he was flipping through a volume of the Annual of Scientific Discovery from 1856. It was a dense, dry collection of reports, summaries, and abstracts. As he turned the brittle, yellowed pages, his eyes caught a heading, "On the Heat in the Sun's Rays." He started reading the summary of the work by a Mrs. Eunice Foote. As he turned the brittle, yellowed pages, his eyes caught a heading. Sorensen stopped. He was a geologist. He knew the history of climate science. He knew the timeline. Tyndall was 1859. This book was 1856. The math didn't add up. He read the summary again. There it was, in black and white. The experiments with CO2, the heating, the cooling, the prediction of a warmer Earth. It was all there 3 years early. Sorensen realized he was holding a smoking gun. He wasn't just reading an old book. He was looking at a crime scene where the victim was the truth. He published his findings in a geology journal, simply pointing out the discrepancy. Eunice Foote's pioneering discovery of greenhouse warming, he called it. It was a quiet publication, much like Eunice's original paper, but this time the world was ready to listen. The internet picked up the story. Historians of science began to dig. They found the original reports. They found the biographical details of her life as a suffragette. They reconstructed the experiment. The narrative began to shift. It was a slow, tectonic movement, but it was unstoppable. Wikipedia pages were updated. Textbooks were revised. Conferences on climate history began to include her name. We realized that the father of climate science had actually followed in the footsteps of a mother. This vindication is not just about correcting a date on a timeline. It is about something much deeper. It is about recognizing that insight and genius are not the sole property of the privileged. Eunice Newton Foote worked in isolation, without the support of the Royal Society, without the validation of her peers, driven only by her own curiosity and intellect. She looked at the invisible air and saw the machinery of the climate. We now know that the first person to predict that burning carbon would cook the planet wasn't a bearded academic in a London lab, but a woman in New York who refused to be ignored, even if it took a century and a half for us to hear her. We now know that the first person to predict that burning carbon would cook the planet wasn't a bearded academic, but a woman in New York. Today, when we talk about the climate crisis, we stand on the shoulders of giants. But for too long, we have only looked up at the men. Eunice Newton Foote reminds us to look closer, to look at the margins, to look in the shadows of the archives. She reminds us that history is not just what is remembered, it is what is chosen to be recorded. And finally, after 160 years, we are choosing to record her. She was the first to see the fire that would engulf our future. And though they tried to blow out her candle, the light she struck in 1856 burns brighter today than ever before. She is no longer the footnote. She is the headline.